Okay, so for analysis assignment 3, we're going to look at a new worksheet. You can open it here. We're going to basically focus mostly on this shoe sale data. So I already have it open. And in the data set, you have just a little bit of information. One thing to quickly note is that if you're making decisions based off of data, you should have enough data to make a decision with. So just a gut instinct tells me this is not enough data to make a decision, but it gives us a starting place, so that's okay. Ideally, you'd have hundreds of rows of data before you start making decisions, but again, this is good for practice and for this assignment. Now, the first thing we want to do is take a look at, you have an X variable and a Y variable. Typically, the X variable is your independent variable and your Y variable is your dependent variable. So the way they have this set up, the price of the shoe is dependent on the number of shoes sold. Now, it doesn't really matter which way this goes in a correlation test, because we'll get to see it either way, whether this was X or whether this was Y. But typically your independent variable is the variable that you can manipulate. And then the dependent variable is that which is, maybe in this case, we want to know, for example, if we looked at grades, are your grades dependent on how much time you spend on your homework? So your grade would be the dependent variable, and how much time you spend on your homework would be the independent variable. Hopefully that makes more sense. So to look at mean, we did this in the first analysis assignment. You can do this with a function, and you look at average. Average is the mean. If you actually type in mean, it will bring up average. They don't have a function called mean. And then it wants to know the average for X. So there you go. And hit OK. Again, that's just giving you the average of what these, I think there's 7. Let's see. Yes, 7 pieces of data is 16.71. Then it wants to know the variance. So there is a formula for variance. Let's pull this up. VAR is a good place to start with variance. Now you have variance P and variance S. If you have the whole population, you can use variance.P or VAR.P. If this is a sample, which clearly this is a sample, you'd use VAR.S. So let's put that in. Again, you're going to highlight your data set and then hit OK. All right. And then for standard deviation, we're going to use another function. Here we go. So STD, you have several different standard deviation formulas. Again, the main thing is if you have the whole population, you can use P. In this case, it's a sample, so we're going to use S. And then this time we're looking at the price. So we're going to bring that down and hit OK. And then we want to know if there's a correlation between both of these variables. Now I'm going to show you how to do this several different ways. So hang in there with me, because when you do this in Excel, it will give you correlation, but it does not tell you if it's significant. So we need to do a few extra steps with that. All right, so just a formula for correlation is here, CORREL. And you want your first data set, and then you want your second data set. All right, and that gives you an R value of 0.02. Now that's good, but it doesn't tell you if that's significant or not. So to get significance, we need to know if that is what your p-value is. To do a p-value in Microsoft Excel, we need to do an add-in. So if you go to File and go to Options, and then go to Add-ins. All right, so once you're in add-ins, let me move my zoom. Then you can see Analysis Tool Pack. Yours is probably inactive if you haven't already used it, but go ahead and find Analysis Tool Pack, hit OK, and then it will add it for you. In this case, I already had it added. So now you can go to Data Analysis, and find, in this case, we first want to find regression. That's how we're going to find our p-value. Now, there are other ways. If you're searching online, you can see that there's a way you can look for a p-value using a t-test. That's not the way that we need to do it here. T-tests look at differences between groups, and we're not looking for differences between groups. We're looking at relationships. So relationships mean correlation or regression. Let's go ahead and look at regression. And then we need to add our X and Y variables here. So our Y is here and our X is here. And then I didn't include labels. If you do include the label, that's fine. Just note that you include it. And that's about all that we need right now. Okay. So what this does for you is provide you with a p-value. And this is why this is so important that we take this extra step, because the p-value is 0.96, which means this is not significant. So although it appears there's a relationship, it's not a significant relationship. Now it also gives you, if we open this up a bit, it gives you that correlation value here, 0.02. And if we come back to our shoe sales, you have 0.02, but what we don't have again is that p-value. So what you're going to need to do is include that. If you hit equals, you could just come right over here and put that in. So that would be your p-value. Typically when we report that, you only need to report 2 decimal places. So there you go, 0.96. And the general rule is if it's less than 0.05, then it would be significant. In this case, it's more than, so it is not significant. All right, so I want to show you how to write this up. Okay, so this is a basic template. Every time I run correlation or regression tests, or pretty much any statistic for that matter, I have to retype the output into an APA formatted table. So this lets you name your table. In this case, we'll call this table 1. It's a Pearson correlation among variables. You have your mean and standard deviation, which we calculated. We also have, here's your 0.023, which is the R value that you calculated. If we come back over here to this, and we actually expanded a bit, you've got the 0.023. Then what this table does not show again is your p-value. Now, if you had an asterisk here, we would report it like this, and use the superscript, but we don't have the asterisk. But if you did, it would indicate that it was either less than 0.05 or less than 0.01. In this case, we don't have that, so you can take that off. I'll even take this off because it's not there. We want to remove this because that's telling us the asterisk would indicate a statistically significant relationship. There is not an asterisk, so I'm going to take that off. But now what we can do is talk about the Pearson correlation coefficient was computed to assess the linear relationship between the price of shoes and the number of shoes sold. There was an insignificant positive relationship. We know it was positive because it was, our R value did not have a negative number there. If it did have a negative number, and we'll come back to your Excel spreadsheet, you would see the negative sign. That just means, it doesn't mean it's necessarily negative as in a bad way, but an inverse relationship. That would indicate that as more shoes were sold, the price went down. And that's not what happened in this situation. So it is a positive relationship between the two variables. Now what we need to do is look at how to write this up. So your R number, you have R degrees of freedom, and to get your degrees of freedom, you take the number of items or number of data points and minus 2. In this case, we come back, you had 7. So 7 minus 2 is 5. That's where we have R, and then 5 equals, then you put in your actual R value of 0.023, and then you need to put in your p-value. And if you remember, we did your p-value separately, and here it is. And we can reduce that down to 2 or 3 numbers. You could do 2 if you wanted 3. I'll go ahead and just do 2. There you go. In fact, here it tells you a little bit more information. So R is Pearson correlation should have at least 2 decimal places. You drop the leading 0, so we don't have a 0 here. We just take that off. The degrees of freedom is your total number of items. So you had 7 minus 2, that's 5. And then the p-value, we also do not report using a leading 0. All right, so that's how you would report it. And that's for your correlation test. Let's go back to your assignment now. So we've used Excel to calculate the mean, the variance, the standard deviation, the correlation, and then it's asking you some questions about what we found. As far as the strength of the relationship, let me go back to our document here. So Cohen has a 1988 article that talks about effect size for your strength. If it's a low effect size, it's 0 to 0.29. In this case, it's 0.23. So that would be a low relationship or a small relationship. If it was moderate, it would be 0.3 to 0.49, and anything above 0.5 is high. So that's talking about your relationships with the R value. All right, so we talked about the inverse relationship, meaning if one goes up, the other goes down. And if we have a perfect match, you'd have a 1. So in your output, if we come back to this, I actually want to do a correlation. Now, if you go back to data, you go to data analysis, and then go to correlation. And here you can highlight all of this information. I'm not going to include the labels, and hit OK. Now you can see a 1-to-1 correlation when column 1 matches column 1. That means it's a perfect match. When column 2 matches column 2, that's a perfect match. So that's where you get the 1. All right. Okay. And then the next part of this is to look at these other tables. So let's come down here to foundation bid. Here you have one called foundation bid, estimated pile length, actual pile length. What we want to do is take a look at that next worksheet. There we go. And in this, we can do another correlation table. In this case, let's go ahead and include the headings or the labels. We actually have more data this time, so I feel a little bit better that this might give you better results. Let's hit OK. All right, so as far as the strength of the relationship, it has a strong relationship with an R value of 0.796 or probably 0.80. If we go back to that document, 0.80 would come in as a high relationship or a strong relationship. So there is a strong relationship there. We still don't know the p-value though. So let's go back to pile foundation, look at regression. This time we'll include the headings. And mark labels and hit OK. Let's come back. Oh, this is where we have the X and Y. So let's change that. Here we go. We'll do one at a time. And this one. Okay, and hit OK. Now you can see your p-value. Again, that p-value is above 0.05. So I would say, even though it showed a strong relationship, it's not significant. You can also see p-values down here. So this is the same as it is here, just not a significant relationship. And that happens sometimes. I'm not familiar with the data set that well, but just looking at the names, estimated pile length and actual pile length, I'm not sure that what those are indicating. So the next one is call center turnover. So let's look at that one. All right, now with this, when you're looking for correlations, if you go back to data again, data analysis, we can start with regression and look at the p-value, or we can start with correlation. But when you start with correlation, you can put everything you want in one. So we can just put all of this in one. And we do have the labels, yes. So I'll leave that and hit OK. Now you can see this is a little better view from what we had before. You can see the one-to-one correlations all the way down. That just means that we're looking at gender compared to gender or age compared to age. In this case, we have some inverse relationships, and that's shown with the negatives. And it doesn't mean that that negative is less than. It just means that it's an inverse relationship. So if I compared, for example, this 0.038 to this 0.16, the 0.03 is still smaller than 0.16. The negative out here just means it's an inverse relationship. That's all. Okay, but now to do the regression testing, we would have to look at individual items. Let's go back to this. Take that out. Well, here we go. Go back to our call center information. And we have, maybe we want to look at gender with, go back to call center. Length of service. We could do that. And still the p-value is above 0.05. Let's try something different. Data analysis, regression. And take these out. So we want to make sure that length of service is our dependent variable. And maybe we'll look at starting age as our independent variable. And let's look at our p-value. Still too high. Okay. Okay, so just to clarify, why is our dependent variable? We want to know which of these independent variables are either relating to or predicting length of service, so their tenure. Let's try this again. Data analysis, regression. Let's put in our Y variable here. And we've tried those two. Let's take a look at prior call experience. Oh, did I hit the right button? Let's make sure. Nope, I didn't. There we go. And then we'll look at prior call experience here. So unfortunately in Excel, you have to do these individually. If we use another tool such as SPSS, then you don't have to do that. But for the sake of this class, we'll use Excel. Okay, let's try this one more time. So prior call experience was not significant with length of service. Let's see if college degree is. college degree, and hit OK. All right, almost. We're very close. Technically, it's the closest that we've been, but it's still not significant because if we round that, we're going to get to 0.06. And what we're looking for is something below 0.05. So technically, none of these variables in the call center document are statistically significant with the length of service. So it's information, but we could not make a decision based off this information because it's not significant. What we often have, especially with data analysis, is where people will run a test like this using let's go back to this shoe sales. Using this formula for correlation, they get this number and think, okay, there's a small relationship. And that's just not the case. If we go back to let's see. Here we go. This is the relationships for length of service. And you can see positive and negative relationships. Some of them, this one's a large one, but there's no statistical significance. So you really can't make decisions based off of this. Hopefully that's helpful and you can understand that. All right, so I think that takes care of everything in our, oh, we have the infant mortality one. Let's take a look at that real quick. And as you do this, you'll end up with a lot of different worksheets at the bottom. Okay, so let's do this one. Your data toolbar, go to data analysis. Let's look at correlation. We are going to put in all of these, include the labels. And we have label, and then we're going to hit OK. And you're going to get an error. And the reason for the error is that the country names are not numeric. So to fix that, we would need to do, let's cancel that. We would need to code those. So let's do a country code. And you can simply just label it. And you could do that, or we could omit that data. So it may be that we don't need to have that data there. But if you want to include it, you would need to have a country code. We can't include any sort of alpha characters whatsoever. Now, let's go back to data analysis, look at correlation. I'm actually going to leave that out. Just look at mortality, density, and literacy. And then we have labels, and we'll hit OK. So again, we see some inverse relationships or negative relationships. And this one's rather large because it's 0.8. But we don't know if these are significant. So we're back to that. So mortality, density, and literacy. Let's take a look at regression. Okay. And then we go back to the call center data. You can see Y is your dependent variable. So let's pop over here. You can make the decision which one should be Y. I'm going to go with, actually, let me cancel that. I'm going to go with the mortality as Y. I want to see, does the density of the country relate to mortality, or does the literacy of the country relate to mortality? So these are going to be my X variables. Go back to data analysis, regression. And so in our Y value and our X value, take those out. Now, Y, we want this. And then we'll have to do these one at a time. Let's start with density. And hit OK. So here's your significance value or your P value, still above 0.05. Let's try literacy. Oh, hit data, data analysis, regression. We're going to take out density and put in literacy. So in other words, does the literacy of the country have anything to do with the mortality rate? And according to this data set, it does not. Okay, so, well, I think we get an A for effort that we've tried. But this helps you again go through all the data. We've exhausted your analysis to see, is there a relationship between these three variables? You looked at if there was a relationship between these 5 variables, and you looked at relationships between these 2 variables, and then you looked at relationships between these 2 variables. In all of them, the relationships were not significant, but you can go through the exercises to see what it looks like, go through the process. And what I often hear, especially with dissertation students who have spent a whole year collecting data, running these tests, and then they find that their data, the findings from their data are insignificant, they oftentimes get pretty bummed out. They've spent a year of their life doing it. But even though the test comes back as insignificant, the findings are still significant in the fact that we can now make a decision that these 2 variables by themselves, we can't make decisions on them. And again, these variables by themselves, we can't make decisions on them. So if I was a business owner or somebody making decisions in an organization, I would need that information, that significant information for me to know, so that I don't make decisions based off of bad data or erroneous facts. All right. Well, I hope that helps. And if you have questions, please reach out.